The next topic we are going to discuss in the fifth unit is repulsion motor. So under this we are going to discuss the following contents: introduction, construction of repulsion motor, working principle, types of repulsion motor, advantages, disadvantages, and finally the application. Now let us discuss about the introduction of repulsion motor. So the repulsion motors are mainly classified under the single phase AC motors. So similar to the AC motors, it also has a stator as well as a rotor. The stator is normally connected to the AC supply, whereas the rotor is connected to the commutator as well as the brushes assembly. And this type of rotor connection is very much similar to that of a DC armature. And let us look into the detailed construction diagram of the repulsion motor. And here we have the stator windings at the top, which are of cylindrical type, in which the slots are provided, where we have the accommodation of armature conductors, whereas in the rotor will be of smooth cylindrical type. The brushes of the rotor are normally short circuited, and the rotor is connected to the commutator externally. From the stator, we are taking the stator leads outside for connection to the AC supply. The rotor windings are normally of distributed type, and it may be either a lap winding or a wave winding. And the brushes used in the rotor are normally made up of carbon in order to conduct the current using the armature. Let us discuss about the construction of the repulsion motor in detail. The repulsion motor has operating characteristics similar to that of a DC series motor. It has a stator winding which is very much similar to the stator winding of a split phase motor, but without starting winding. The rotor is similar to that of an armature of a DC motor, but it has no electrical connection to the supply. The brushes are normally short circuited. Now when we look into the first diagram, we can identify that the stator leads are taken outside for connecting to the AC supply, whereas when we look into the second diagram, we can identify that the stator slots having armature conductors accommodated and the brushes are short circuited, and the armature slots are numbered from 1 to 16. The difference between the AC series motor and the repulsion motor is that whenever we are providing AC supply, the armature gets the voltage in case of the AC series motor through the conduction, whereas in case of a repulsion motor, then the stator windings are energized. By induction principle, the armature gets the voltage. Now let us detailedly discuss about the working principle. Repulsion motors are working based on the principle of repulsion between the two magnetic fields. Whenever the stator winding is energized, a revolving magnetic field is produced, and because of this a flux will be induced, and this flux links the rotor winding, and a rotating magnetic field is produced in the rotor also. Whenever the stator rotating magnetic field and the rotor rotating magnetic fields are having a repulsive force, because of this a repulsion torque will be exerted, and this torque is essential for the rotation of the rotor. Now consider a two-pole motor with a vertical magnetic axis. The armature is connected to commutator and the brushes are short circuited using a low resistance jumper. When AC supply is given to the stator winding, an EMF or electromagnetic force is generated in the armature, and the direction of this alternating current is such that it creates a north pole at the top and a south pole at the bottom. So the direction of this induced EMF is given by the Lenz law. According to Lenz law, we know that the induced EMF opposes the cause producing it. So EMF is given by minus n into d pi by dt. Now let us detailedly discuss about the circuit diagram of repulsion motor. For ideal case, since the motor winding has a north pole at the top and the south pole at the bottom, we will be having the circulation of currents like this. For a short circuited case, the north pole at the brushes are short circuited. The A and AA brushes of the motor are short circuited, so we will be having a north pole at the top and south pole at the bottom. And position for clockwise operation. If the brushes are shifted by certain angle from the vertical axis by 30 degrees, then the north pole produced in the stator and the north pole produced in the rotor will be having a repulsive force, and this makes the rotor to rotate in the clockwise direction. Similarly, if the brushes are shifted by a minus 30 degree or a negative angle from the vertical axis, the repulsive force between the stator as well as the rotor will make the rotor to rotate in the counterclockwise direction or the anti-clockwise direction. Initially, when the rotor is in the starting condition, the EMF is very much more, and the inner cage winding reactance is also very much higher, so the current flow is very much smaller. And when the rotor gets speeded up, and during that condition, the rotor frequency EMF will be very much lesser, and the rotor reactance will be lesser, so a huge amount of current flows. So the brushes in the rotor are short circuited and they continuously ride on the commutator. This is the main working principle of the repulsion motor. And let us look into the types of the repulsion motor. So the repulsion motors are classified mainly based upon the position of connection of the windings. So they are classified as compensator repulsion motor, repulsion start induction motor, and repulsion induction motor. Now let us detailedly discuss about the torque speed characteristics of the repulsion motor. So the characteristics A represents the torque speed characteristics of repulsion motor, whereas the characteristics B refers the torque speed characteristics of the induction motor. During the initial condition, the rotor reactance is very much small, very much higher, so we will be having only a smaller current, so a smaller amount of torque we will be getting during the starting condition. So when the motor is getting speeded up, the more amount of current flows, so the starting torque is also very much higher. So when the speed goes on increasing, the torque is constantly reducing. The speed torque characteristics of this motor is drawn like such that the speed regulation is very much good and the starting torque is also very much higher. And even when unexpected heavy load occurs, the motor is capable of producing sufficient torque to run the rotor. The repulsion motor is well adapted to small crane services or other applications where high starting torque is preferred and the great speed regulation is not at all objectionable. And whereas the characteristics B represents the torque speed characteristics of an induction motor. Next, let us discuss about the torque versus load angle characteristics. Now this characteristic shows the relation between the starting torque and the brush shift movement. When the brush shift is in the positive direction, the starting torque is increasing to a maximum value, and after that it goes on decreasing in the positive side. Whereas when the brush shift angle is in the negative direction, the torque increases in the negative direction and it finally reaches to zero value when it goes to the infinity. So the operation takes place only between minus 90 to plus 90 degrees. So the total 180 degree direction, 180 degree mode of operation of brush shift determines the starting torque value. So the direction of the torque is same as the direction of the brush displacement. Now let us detailedly discuss about the advantages and disadvantages of the repulsion motor. The advantages are the starting torque is high, good speed regulation, and even for heavy unexpected loads, the sufficient torque can be developed, and the starting torque is very much less. The disadvantages of the motor, there is a possibility of occurrence of spark at the brushes, and because of this, power factor is also very much less at low speeds. The speed at the no load condition is very much higher, and it is very unsafe because the dangerously high speed is also possible. Brushes and commutators exhaust quickly due to the heat generated and arcing at the assembly of the brush because they are short circuited by wire mesh. Now finally, we will discuss the applications of the repulsion motor. The main applications are they are used in the farm motors and film winding machines, hoist machines in the textile, machines for floor maintenance, printing presses, air compressors, pumps and fans, laundry equipments, high-speed lifts, mixing machines, machine tools, air pump, mining tools, petrol pumps, and drive compressors.